Hello again, YouTube, and today we are going to be looking at the current state of all three of my robotics projects. So first of all, you may ask why there are three projects instead of two projects. If you have viewed my channel at all, you will know that I am working on a wheeled robot and a walking robot, and I have been working on each of these for quite a while. Well, I additionally got a new robotics projects. It is the smaller robot. This is one of those robot kits you can buy off of eBay. You can see I'm almost finished with this one. That's kind of why I bought this one, because I realized that these two are taking quite a long time and I want to have a working robot just to test stuff. So that's where this one is. As far as this goes, I bought the base of this. It's just a piece of plexiglass with the wheels and the motors. And then I got an ultrasonic sensor in Arduino, the small one, and one of these little motor controller circuits. And you can see on the bottom of it, it has a battery pack and a wheel. These are little motors. They do not have a lot of torque at all, but it should be enough just to move this along. What I'm going to do with this is I'm going to solder this Arduino to this board. Well, no, I'm not going to solder the Arduino. I'm probably going to get header pins, so it'll be popped up more like that. And then I'm going to wire all of these sensors and motors, the motor controller, to this board, and then I'll have the power coming into it. And it will basically be able to avoid obstacles using this ultrasonic sensor. And there's also a humidity sensor here. This calculates temperature and humidity, and that's because this ultrasonic sensor uses sound to bounce off of whatever obstacle it's in contact with. And what I hope to do is to use this temperature and humidity sensor with this ultrasonic sensor, which will make this more accurate. If you don't know how this works, it calculates the speed of sound, and you could either just use a standard calculation or you could calculate it more accurately using temperature and humidity, which is what I have here. So this is this little robot. That's probably going to be finished soon. Up next are these two robots, the main projects ones, and I don't think I've made a video about this one in a while. This is my wheeled robot. I haven't done very much to it, and you could see what's going on with it. You could see it still has all the motors, everything as it was configured previously. But I have the wheels taken off because I'm going to do some changes with them. Mainly if you see how I mounted these wheels, is that it's a piece of, this is HDP plastic, and then there are 4 bolts, well, no, 3 bolts, these are 1/4 inch bolts, and they go through the wheel and mount like this. Okay, so it was working like this, but the problem is that this HDP does not really screw well into the motor. It can come loose very easily, and it's not exactly center. I just marked these off by hand, so that's in need of fixing. There's also a 3D printed one right there. That one's centered properly and it holds well, but these bolts I found are just too big for this purpose, so I'm going to be switching to smaller bolts. These machine screws, these should be more than enough to hold the wheels in place. Just replace these with these. But obviously, of course, these holes in the wheel, they're already where they are. So I got 4 new wheels, and I'm going to be doing the same thing with these, using 3D printed motor hubs, kind of like this one right here, but with the smaller holes. So this thing is going to be getting entirely new wheels, entirely new wheel hubs. And that's not the only new thing that it's getting, it's also getting new motor controllers. If you can see right now, it doesn't have motor controllers. To control the motors, it's actually using relay H bridges, which is fine. The relays make it go back and forth, but it doesn't have speed control. And I thought I was going to just run it at a lower voltage, but it turns out these motors, especially when you wire them up in parallel, which is what they are, they're 4 motors in parallel, they would really rather have 18 volts, not 12 volts. There's just not enough power from there. So I'm going to power it using 18 volts, which is going to be controlled by a PWM controller, which is what these are right here. I have 4 of these controllers. If you want to see them, they come in bags like this. See, here's one. Here's the other one. So these are the other ones. They're still in their bags. I'm going to take them out, and then they look like this. And then what I'm going to do is I'm going to rip out all of these, rip out all the electronics. Also, these wires are probably way too thin. I thought I could get away with using these thin wires. I think they're like 20 gauge or 18 gauge at the most. They are very thin wires, and especially this thing right here, this goes to all of the motors. You can see it has 2 of these power pole connectors here and 2 of them here. That's because this one just runs 2 motors and these 2 run in our 2 motors. So the main power is coming through these 2 wires, which are the same gauge as these wires, but it's running 4 times the amperage. That is not good. So I'm going to upgrade everything to these PWM controllers. We are going to be able to control the speed. I'm going to rip out all of these electronics, put the PWM controllers here. So we are going to be able to control the speed, and we are going to have thicker wires. These are much thicker wires. They are 12 gauge wires, and I have 12 gauge wires powering each of the motors. I think I'm fine leaving these thinner wires on connected to the motors directly. It's just coming off of the motors. There's going to be 12 gauge wire in between all the motors. Connecting them all together, there will be this thicker gauge wire. Also, if I need to, I could use this wire, which is thicker gauge wire. It's 18 gauge or 14. It's thicker wire. Yes, it's 18 gauge wire. This is 18 gauge wire. So, and I could take out this 20 gauge wire, put 18 gauge wire on it. I don't think I really need to do that though. So I'm going to change the wiring for that. The Arduino, I'm probably just going to leave the same as it is. And that should be fine. Also, for the power distribution, instead of having this cable, which is just 4 connectors, I'm only going to use power pole connectors connecting the motor to the motor controller. Coming off of the motor controller, where this one is, I'm just going to have this thicker wire, and they're all going to go into 2 bus bars. These are grounding bars I got at the home improvement store. These are for line voltage power, so it should be fine running just 18 volts through them. And these are electrical blinking plate covers. So what I'm going to do is I'm just going to bolt these 2 things here. So one of them would be negative, one of them will be positive. I will run all the negatives through here, all the positive through here, and then coming off of this, there will be connected to the main power source, which will also run through a fuse. So this is the fuse. I will have a fuse through here. I think it's, what do these all these 4 motors should consume only up to 3 amps, I guess. So 3, 6, 12 amps, so maybe a 10 amp fuse, something around there. I will have to measure it and actually calculate the values of fuses, which I will need, but there will be a fuse and then that will connect to a battery. Note also the gauge of the wire on the fuse is also 12 gauge wire. This is actually automotive wire, so that should be good enough for what we're doing. That's it as far as this robot goes. I don't know what I'm going to actually be programming it to do. Probably the same thing as that one at first. I eventually want to have like an arm on it or something. And I will also use it to test computer vision and stuff like that, to navigate around. But that's farther ahead than we're along. We're just making sure all the electronics are working. Now moving on to my favorite robot, the one which is the oldest one that I'm working on, and probably I'm not going to finish the longest because it's so complicated, is this walking robot. I think the last time I showed this walking robot, the torso piece was on top of the legs. I've taken it off just because I need to do a lot of work on this piece. You could see that I have the gears. It has several gear reductions. You can see what I plan to do is, this is a square and it goes through a square hole in this gear, so it's locked by that. But to hold it in place, I have these L brackets. You can see there's one on the other one too, an L bracket, and one here. And you can see it's just spaced by washers here. I wanted to have 2 on each of them, but there's not enough room here. So, I mean, I could run it as it is, but I think what I'm going to have to end up doing is just reprinting this piece and the one over there, obviously, and spacing out these holes farther so we can actually get these brackets in place. And that, of course, will change all these mountings. These gears aren't mounted in place at all. So I can probably just have a shaft collar on either end of it. That will allow me to change the position of either of these gears as I choose. And once we have these in place, I also have 2 more reduction gears. So that one would go there. And there's another one that looks like this, which will go on this side too. One thing that I'm going to have to do is I'm going to actually have to calculate what these reductions actually are and compute that all together. I wasn't really paying attention when I made this, I just wanted the gears to be slower. I barely knew how to make gears at all. And now that I know, I have to actually compute what kind of reductions we're getting. And of course I have this other gear which actually leads to the motor. You can see this is another drill motor, and this motor has wires on the end of it, which are from that big spool of wires. I'm going to use this spool of wires to do all of the motor wiring on this walking robot. So I might use some of it for this robot, but it's mainly for this one to connect the motor's wires. And this is what it's going to look like. You can see I have heat shrink tubing on the wires, and it's going to come off of here. From there, it is going to go into some new power pole connectors. I bought some more. Yeah, I have. This should be enough for most of the robot. At least for the bottom half of it. If I build arms and stuff, which I'm not certain I'm going to do for this particular robot. Mainly I just want to get it to walk. But if I do build arms and stuff like that, I may need to buy more of those. And I'm probably going to do this after I do the stuff for this robot, just because I want to get all the power distribution stuff working to run multiple 18-volt motors at once from this robot and not have to learn it all on the one that's supposed to walk. So this is a lot of the stuff I'm doing for this robot is so I can learn how to do it on this robot. And also a lot of the stuff I'm doing on this robot is so I can learn how to do it on this robot. I guess that's how I would rationalize how I'm doing these projects. Which is kind of weird since I started this one first, and then I started this one, and then I started this one. I guess what I did is I started this one, I realized I did not have enough skills to build this robot, so I decided, okay, I'll build an easier one. And then I realized the same, that I did not have enough skills to build this robot, so I started an even easier one. And how I'm going to plan to finish them is I'm going to finish this one first, and then this one, and then this one. So I guess that's the logic I have behind these three projects. Anyway, I'm going to get these motors going. And one thing to note about these motors is it's using the mounting system for the drill. So to lock it in place, you have this reverse thread screw, and there's the shaft of the motor. And if you have the screw on, it is very tight, and it is able to move this gear from the motor. Which, even though it looks like I have two of these gears, it's not actually the case. This one is not secured at all because the bore of this gear is slightly too big. So I changed it by about 1 millimeter when I made this one. But of course, that does mean that I'm going to have to take the files for this one and print it again to replace this one, which is something I have to do. So I have both of these motors also as well. More stuff with this torso piece. There's a lot of work to do. I have still bolts to put on here. I have see these two pieces that go across. There are two more that go on the bottom. That is kind of important because I don't want it to flare out on either end. I don't know if it will do that, but that's to prevent it. And I already cut them, so I might as well do that. Also, which is positional control. You may be wondering how I will control how these motors go to which position. And I'm going to be doing that using potentiometers. I bought a whole bunch of these. And these are designed to stick in a hole that is in here. So yes, there's a hole here, and the potentiometer has a shaft, and it's supposed to go in there and fit snugly. If you may see, it doesn't really fit at all. If I wanted it to fit, I could probably drill it out, but as you might have recalled me mention about a few minutes ago, I'm going to have to remake this piece. So when I remake it, I should remake that as well. And I have these pieces as well. These are just copies of these, but for the top gear. And once I have that, most of this torso piece is done. Will be done in a way so the gear transmission is working properly. After that, of course, I have to make more 3D prints to mount the motors, and they'll go something like that. And that's how that would work. It would have positional control, the motors will be mounted, and I think that's all I would need to do for that. Moving on to the legs. These legs are actually, they're going along just fine. One thing that I know I still need to do is I still need to put these pieces like this, right, with bolts on either end, screwing it in. I need to put these on all of these other parts of the robot. These metal ones are kind of off center, and that is putting stresses on the motor, which is causing it to not turn at the proper rotations, basically. And I have to do that on all those motors. Also, see how the drill wires are still connected to the motors on the legs. I'm going to have to do the whole thing with this wire and the heat shrink tubing like this on all of these motors. And then of course I have the feet of the robot, which are going to be made out of foam. And this foam is going to go under the toe of the robot. So the robot will not directly contact the floor with metal as it is doing right now. It will have foam feet. This is pretty thick foam, it's 1/4 inch. I might even have 2 layers of this on each of the feet. And that will make sure if there's bumpy surfaces, like for example this tile, it has different surfaces, like this area is higher than this one. That will not affect this robot because of the foam. I am going to have like gyroscopes and stuff just to make sure it balances correctly. But this should be a low-tech solution for a lot of problems I may face. Also, another thing which may or may not be an issue is this motor right here is, you can see it's broken. I fixed it with solder and hot glue, but I think it might be coming off again. Yeah, you can see the black part is the bolt. So what I think I might have to do is I might use super glue and put it back together again. It looks like it might be okay. Yeah, you see this part is melted together, so this part should be fine, but it's coming off again here. I thought I could use hot glue to fix it. That really didn't work. So I'm going to use super glue. And if that doesn't work, I'm going to have to buy another motor and modify it in the same way which I had. I think I actually have more of these motors somewhere in storage, so I might be going to use that. But one thing that I will not do is I will not take motors off of this one and put it on there. That's because I have to finish this one. So in the end, I should have 3 working robots, which are all working at the same time. I'm not scavenging parts to put it on either one, which often, though it can help make me spend less money and get things done faster, I would like to have a working robot at any particular time just to test stuff and the like of that. So that is the update of every robot project I have right now. Some of them are farther along than others. And one thing that I don't like is I'm kind of in college right now, and a problem with that is whenever I have breaks, like I'm on spring break right now, it's hard to build some momentum in building these projects. A lot of the times I have some time off, and when I am able to do something, I just spend a while trying to figure out where I left off, and I can't actually get into the actual technical problems of what I need to build for these. Like for example, I still need to calculate the angles of these and how this motor will move for each rotation to make the leg go forward. That's going to be quite a bit of physics and stuff, so I have to do that. Probably not going to have that going until the summer, maybe. But what I think I'm going to do is I'm just going to organize all of these projects into a box. So everything for this robot, like these pieces, they're all going to go in this box. Everything for this robot is going to go in that box. Everything for this robot is going to go in that box. You may be wondering why this, as a bigger robot, has a smaller box than this one. It's because there are wheels in that box. A lot of this robot is just going to stay outside of the box. So what I'm going to do is I'm going to organize all of these robots into either box, and I'm going to try to make a list of what I need to do for each robot, and then I'll have a better way to solve the problems one by one and then actually get this done. So that's going to be the next video probably, but this video's gone on long enough. Goodbye then.